All right. So, y'all, we're going to talk about set concepts today. So, a set is just a collection of objects. Oops, get my pencil. Boom, here we go. Just a collection of objects. The things inside them, y'all, we call them elements of the set. Okay. So, when we're talking about sets, like here's an example the sets of the days of the week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, right? And we use capital letters, y'all, to describe uh, the name of the set. So, like W for the days of the week. Okay, one of the more important things we're going to talk about, y'all, is something called roster form. Roster method or roster form is just simply to make a list. Okay, so if you notice right here, y'all, they made a list: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and they put commas in the middle. Okay, so it says right here, can we list all the elements or all the letters of the word for? So the letters in there would be the letters F, O, U, and R, right? Okay, now the next one here says, can we talk about the seasons? Okay, what are the seasons that we have? Spring, summer, fall, and winter. Okay, those would be our seasons, right? I know in the valley we don't have a lot of those, but we're supposed to. Okay, the empty set. The empty set is the set that has nothing inside it. The two symbols we use for the empty set is having those little braces with nothing inside it, or a zero with a slash through it. So we're going to see if we can figure out which is the empty set. So the first one actually is the set with the number zero. There's something inside there. It's supposed to be blank. That would be the empty set, but that has the number zero. This is not even a set, it's just a number. Okay. Numbers that are smaller than four. Look, y'all, one, two, three. Numbers that are bigger than 10, 11, 12. And we could keep playing those games, right? So there's stuff in there. A square with exactly three sides. Y'all, a square is supposed to have four sides. So this right here, D, would be what we call the empty set because there is no square with exactly three sides, okay? All right, so now let's take a look at what we got here. Universal sets and Venn diagrams. Okay, so the universal set, y'all, is going to be the set that's going to have a whole bunch of elements in there, and then the Venn diagram where the circle A is going to be stuff inside the circle that's still inside the big rectangle, okay? So look, let's take a look at this first problem. Let's see if we can figure it out. The universal set. The universal set says we want all the numbers inside that red box. Usually, excuse me, usually people say 7 and 9, and they want to stop there. But everybody, all the numbers inside the red box, y'all, the numbers 1, 5, and 6 also happen to be inside that red box, right? And then we say, what about the circle A? Okay, well, all the numbers that are inside this circle would be the numbers 1, 5, and 6. Okay, and then part C, the set of the elements that are in U but not in A. So I'm looking for the elements inside this box, but outside that circle, we'll call that C, and that would just be the numbers 7 and 9. Okay. All right, let's scroll down a little further. Okay, what we have, that's what we call the complement of the set. So the complement of the set A also, look, here's my universal set, here's my circle for A, and then all of this stuff outside of the circle, but inside the square or rectangle is what we call a complement. Those are all the numbers in the rectangle that are not in the circle. So let me show you how we can do an example. Here's my universal set, okay? There's my universal set, boom, right there. Here is my circle or my set A. I want to pick numbers from here except for those. So I don't want to pick the number 1. So I'm going to scratch the number 1. And I don't want to pick the number 3. So I'm going to scratch the number 3. I don't want to pick the 4. I'm going to scratch the 4. I don't want to pick the 7. I'm going to scratch the 7. What am I left with? 2, 5, 6, 8, and 9. Okay. That's what we're left with. That's how we find our complement. Okay, now when we're talking about the intersection, y'all, refers to what we call the overlap, the numbers that are in both, the numbers that we have in common. Okay, so look, this is what we're going to do. The intersection. The intersection, y'all, looks like a little upside down U. Okay, I want to know what numbers do we have in common. So the numbers that happen to be in both would be 8 as well as 10. So 8 and 10 would be the numbers that we have in common. Okay. If I look at the next set, 1, 3, 5, 7, 9, 2, 4, 6, and 8, they don't have anything in common. So it would be the empty set. There's nothing in common. Okay. Now, let me show you how I'm going to do part C. Part C says 1, 3, 5, 7, 9. Okay. What do we have in common? That little zero with the slash, that's the same thing as the empty set. So what I'm really asking myself, y'all, is what numbers show up here as well as there? Well, there's nothing here, right? So they don't have anything in common. Okay. All right. Let me scroll down a little bit further. Okay, the union. What does the union mean? So, y'all, I want you to think about this right here. Those are my girlfriend's kids. Okay. These right here, those are my kids. These right here, those are the kids that we have together. When we get married and we get a house big enough, all of her kids are coming, all of my kids are coming, and a lo mejor all of our kids are going to come too. Everybody's going to go in the same house. So we're going to put all of them together. Okay. So the union just means, can we put all of them together? So y'all, I'm going to put them in order. 6, 7, 8. I know 8 occurs in both, but you don't got to put it twice. 9, 10, 11, and 12. There's my first one. Okay. Now, we're going to do part B. We're going to put them all together. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Part C, we're going to put them all together. 1, 3, 5, 7, 9, put together with the empty set, which doesn't have anything else. But if we put them all together, y'all, we're still going to have 1, 3, 5, 7, and 9. Okay. Let me scroll down a little bit further. Okay. And let's see if we can do this one. So we want to find the Venn diagram to list all the elements inside the circle A. So look, y'all, I'm going to come back here. Everybody inside that circle. Well, W, C, B, T, but also A and H. Now B, everybody inside that circle. F, V, G, R, D, A, and H. Okay. Now remember what we said, the intersection. The intersection, let me do it like this, y'all. Sorry, let me get rid of that. Boom. Let's come back this way. The intersection is what I call our kids, the kids that we have together. Remember, these were all of her kids. These were all of my kids. The kids we have together, y'all, are A and H. Okay. Okay, the universal set. The universal set, y'all, let's do this. Let's clean up this mess. Let's come back here. Okay, universal set, everybody inside that rectangle. W, C, B, T, A, H, F, B, G, R, D, as well as P, M, and Z. Everybody inside that rectangle, okay? And then I think we got this next one here, B complement. Okay, I'm going to write it up here because I'm kind of running out of room. So, I don't know. Let's go blue. Okay, B complement. Here is the circle of B. B complement says, I want everybody except for those guys. So we're going to pick W, C, B, T, but also P, M, and Z. It's everybody outside that blue circle. Okay. All right, let me scroll down a little bit more. And let's take a look at this next question here. Okay, a math tutor working with a small group of students asked each student whether he or she had studied for a class the previous weekend. Response is shown in the Venn diagram. Who are the people that studied on Saturday? I want everybody inside the Saturday circle. Aaron, Anya, and Alan. Those are all the people that studied on Saturday, right? Okay. Now, my next one here, y'all, says we're going to look for all the people who studied neither Saturday nor Sunday. Well, these right here are my Saturday folks, and these are my Sunday folks. I don't want those. So who do we want? Brad. They're outside that circle, okay? Y'all got any questions? Let me know. I'm happy to help.